All right, here's a quick look at 9D. Now we talked about it a little bit in class, but we didn't have, I think this is a better graph. It's just nice to see something a second time if it didn't quite settle with you. But if you take this one, we're on x equals -1. I've marked, that's the axis of rotation of this picture, and then that darker line you see in there is the y-axis. And because when you're doing shells, remember to take these rolls of toilet paper, it's a cylindrical shell. You think of the thickness of that as dx, because the way I've drawn it in there, you can see the thickness would be in terms of x. So when you go on the y-axis, it's dx for shells, so I've marked that in there. So we're going to do 2 pi with dx as the variable. And the way this works is it's the radius first, and the radius is always x minus the axis of rotation, or axis minus x, whichever is further to the right, and x is basically it's a location within the region of integration, that blue piece that we're rotating, and that's definitely to the right of our axis of -1. So, and then the height, that function is that line, that yellow line that I drew in there, how high that is, how tall the piece of paper, the rolled up toilet paper would be, is the upper function minus the lower function, x squared plus 1 minus the x. That's consistent in the whole interval of integration from 0 to 1. And that's a good sign, because what that means is this is a great shells problem, because I don't have to make 2 integrals. I got some, I'm just throwing out some algebra there. You can look at it. X squareds cancel, x's cancel. Man, this is just perfect. X cubed plus 1 is all that's left. And if you want to rewind and look at this in more detail, just pause and take a peek at it. It's a really nice shells problem. Okay. Now, if we go washer on this one, again, you can just stop this and take a look at it. But washers, since we're going parallel to the y-axis, we're rotating around x equals -1. It's a dy problem, and that's in washers. Remember, if you're parallel to the y-axis, it's dy. If you're parallel to the x-axis, it's dx. And for that, if I'm going to choose the washer method, this is going to get tricky. Because remember, it's outer radius squared minus inner radius squared. And if you look at this, I put in some lines in there of various colors, and it might be difficult to see, so I'm just going to kind of swoop in there with a highlighter and circle it. Look at all those different colors for outer edge and inner edge. There's different outer and inner edges between the region 0 and 1 and the region 1 to 2, if I think in terms of y. So from y equals 0 to y equals 1, there's that yellow and black outer and inner edge, respectively. If you go from y equals 1 to y equals 2, there's the orange and purple outer and inner edge, respectively. All that's to show you is that this is a place where I'd have to do 2 integrals. I'd have to break it up. So if you want to see those, here they are. Here's the 2 integrals that make this up. From 0 to 1, we're looking at y, the slanted line that's in yellow in the picture there, minus a -1, which is the axis of rotation. And then the inner radius, the smaller radius, would be, you see the darker black line in that 0 to 1 region. That's 0. That's the y-axis. 0 minus a -1, the axis of rotation. Okay, and then in the upper region from 1 to 2, the outer edge that you see in orange on there is the line x equals 1. So that'd be 1 minus a -1. That's the x equals 1 line minus the axis of rotation. And then finally, that inner radius would be that purple swooping region, which is the square root of y minus 1 minus a -1, which is again is the axis of rotation. That is a much more complicated integral. Of course, we add those together. So I'm going to go with shells on this one, but I want you to see how the setup goes. You can use either one, but shells is nice because the elements of shells, radius and height, specifically if your height of your shells is a consistent measurement throughout the whole integration interval, then shells is a good choice. Washer method is a good choice if your outer radius and inner radius are consistent throughout the whole region of integration. So there's the story. Hope that helps a little bit. That's 9D.